So I'd like to do an Aleks question that is a great summary of the process of finding a confidence interval and its purpose. So this one says a cell phone manufacturer has hired you to estimate the population mean of the battery lifetimes for all phones of their latest model. All right, so we're trying to estimate the mean for all of their phones. Now, you're going to measure their lifetime by recording the time it takes for the battery charge to run out while a tester is streaming videos on the phones continuously. So you've defined what you mean by the battery lifetime. And then you take a random sample of 45 phones. So you're not going to test every phone they made. You're going to use a sample and record those lifetimes to figure out an estimate for the true population mean. Now it says that we can assume the population standard deviation of the battery lifetimes for that cell phone model is 2.42 hours. And based on our sample, we're going to construct a 99% confidence interval for the population mean for all phones of the manufacturer's latest model. Okay, so what you'll be doing is taking your own sample. So every time you do a problem like this, you would be taking a sample from the population. So every time you take a sample of 45 phones, the results will be different because you don't always get the same 45 phones. So every time you take a sample of 45 phones, you'll be recording the following information. Now, the only thing I don't like about the Aleks question is that they don't review symbols for you here. And so I would just like to do that first, and then I will show you a generation. I'll generate a sample for us. So for now, if you just want to just kind of watch and review symbols. So the number of phones in the sample would be lowercase n, the sample size. The sample mean is X bar. Sample standard deviation would be S. And in this case, though, they give us population standard deviation, and that is sigma. All right, so when we know sigma and we're trying to estimate a population mean, and I think it would be good to just add the symbol there as well, population mean, mu. When we know sigma, the process is going to be based on z-scores. So when we know sigma, we'll be relying on critical values that are z-scores. So we'll get to those in a moment. So after you take your sample, you'll be recording your sample size. And then we need to know point estimate. So the point estimate for the population mean is the sample mean. So I'm just going to add that here, that the sample mean is our best point estimate. So our best single number to estimate mu is the X bar value from the sample, so the sample mean. And then it will ask you for the population standard deviation. We put that in. And then the critical value, we know how to find that ourselves for a 99% confidence interval. However, Aleks will just give you the answers over here for critical values that are common. So 99% confident, that would be 2.576. We would enter that there. And then Aleks is going to fill in the rest for us. But again, I'm just going to review here the standard error. So this is from central limit theorem. That's the sigma over the square root of n. So that's the standard error of the sampling distribution. All right, margin of error. Aleks is going to just give you the answer, but I'm just going to remind you that we know how to find that. It's the critical value Z alpha over 2 times the standard error. And then to create the confidence interval, we again can do it ourselves, but Aleks will give you that answer. And then I will show you how it appears on Aleks. So let me try this. So I'm on Aleks, and we are in homework 7.1, and I'm doing question number 6. And so we've got our batteries. I'm going to take a sample. So when I take a sample, it will randomly take a sample of these phones. And I get the following information. All right, so let me start putting in values here. So for sample size, that was 45. So I'm just entering 45 there. Point estimate would be the value of X bar, your sample mean. So no work here, basically just vocabulary. Population standard deviation, 2.42. So we're not using sample standard deviation. They want population standard deviation. So 2.42. And then the critical value, again, 99% confident, 2.576. So we discussed this notation, and we also discussed how to get this value using the shortcut of a Z interval. So I'm not going to review that here. We're going to just take advantage of the fact they told us the answer. So 2.576. Now they're going to compute these for us. We're going to hit compute. And there we go. So I'm going to scroll down here. And they've given the interval in the form point estimate plus or minus margin of error. And they'd like you to graph the confidence interval with its lower limit and its upper limit based on their results. All right, so all we have to do, let's go with the lower limit. Sorry, let me get my calculator in a better spot for us. Okay, so the lower limit, we would take the point estimate, 5.45, and subtract the margin of error. All right, so the lower limit is 4.52. So I'm just typing that in, and it will move it for us. And then the upper limit, 5.45. This time we add the margin of error, bringing us to 6.38. So I'll put that here, 6.38. So they're not going to ask you to write a sentence, but I'm going to state the sentence. I'm 99% confident that the mean battery lifetime for all phones of this model, I believe with 99% confidence, it is somewhere between 4.52 and 6.38. And I've already forgotten the units, which is always important when we do sentences, hours. So I believe with 99% confidence that the true mean, mu, is somewhere between those two values. So I could be wrong. I'm only 99% confident that I have it correct. And I'll hit check and hope that I got it right, or that would be quite embarrassing. Yay. All right, and that's how you do those problems. The next one is the similar idea.